Welcome to the third part of the lecture in binomial theorem. So let me just give you a recap in Pascal's triangle. So we studied about Pascal's triangle. We studied that it starts with the number 1. But then I told you that all the symbol spaces, the blank spaces, we can give zeros. You don't have to write this. This is just for your understanding that I'm writing it. I'll show you why I'm writing all this. So now make the Pascal's triangle. You just have to add this. 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 1, 1 plus 1 2, 1 plus 0 1, 0 plus 1 1, 1 plus 2 3, 2 plus 1 3, 1 plus 0 1. Then you just have to imagine blank spaces all are 0. So 1 plus 0 is 1, 1 plus 3 4, 3 plus 3 is 6, 3 plus 1 4. I'm liking the song. 1 plus I'm sorry, it is 1. Okay, so you see that, and let me just take off all the triangles, the zeros. So when you do that, you see this thing, you see a triangle, and this triangle is called Pascal's triangle. Of course you can go more than this. I'm just drawn this much. One thing that you'll have to notice is, or you'll remember is that this is a triangle. It has many rows, right? It has many rows like this. One thing that you'll have to remember is, this is the 0th row. This is the first row. This is the 0th row. First row, second row. This is the third row. And this is the 4th row. Okay, so 0th row, first row, second row, third row, 4th. Remember that the row counting starts from 0 in Pascal's triangle. Okay, it starts from 0, 1, 2, 3, 4, 5, and this goes on to infinity. Okay, now knowing this, I would like you, so with this, I showed you that you can do binomial, you can find binomial expansion. For example, if you want to find a plus b whole square, that means the power is 2. You can just go to second row and you can follow this. A square, 1a square plus 2ab plus 1b square. Now, let me show an example with the 4th row. The 4th row. So this is the 4th row, and with this 4th row, let me try to help you. Okay, so let me bring my pen. Okay, a plus b to the whole to the power 4. How to find it? We came to know in the last class that the powers of a starts from the maximum power and then starts decreasing. Then the powers of b starts from the lowest power and then it keeps on increasing. In this case, the highest power is 4. So power of a starts from 4 and keeps going, 3, 2, 1, it goes to 0. The power of b, it starts from 0, the minimum number. It increases 2, 3, and then goes to maximum is 4 because it is the power a plus b, the power is 4. Now, so let me start it. So first, now 1 into, let me change the color for your understanding, a into a to the maximum power 4 into b to the power 0 plus. Now, I didn't write b to the power 0 in the last class video. Why? Because b to the power 0 is 1 itself. Anything to the power 0 is 1, or b to the power 0 is 1, right? So anything to the power 0 is 1. That is why I didn't write that. But even if you write it or not write it also, there is no difference, no problem also. So plus 4 into power of a decreases, a to the power 3, b to the power b power increases, it becomes 1. So from here b power starts. Then a power decreases, it becomes a square. Then b becomes b square. Then a becomes a power increases 2 minus 1 1, b power increases, a power decreases and b power increases to 3, and a becomes here, let me put the plus terms in between, okay, the a plus sign in between. Now a here becomes 1 minus 1 0, a to the power 0, which is basically 1, and then b to the maximum power, that is 4, because from 3 plus 1 4. Yeah, so this is how we make the binomial exponential. So with the Pascal's, with the Pascal's triangle, you can expand any binomial, any binomial to any power. That is the amazing thing of binomial expansions. I mean, Pascal's triangle. But it's wonderful, and I know it is wonderful, but there is a slight issue, and the problem is, for example, suppose the question is to find a plus b to the power 22. How will you find? You will have to draw the Pascal's triangle 1 1 1 1 2 1 1 3 3 1 1 4 6 4. You have to keep going like that till row 22 to find the values, and that is not an impossibility. It is of course possible, but it is not feasible. The meaning of feasible is it is not practical. It is not at all practical, because it will take a lot of time for you to find till row 22. And suppose I increase the number, I give you row a plus b to the power 42. If I just keep on increasing the number, you won't be able to practically find it, because it's too long and chances of making mistakes are also high. So it would be really good, if we could have one formula to, so that we can just with that formula you can find the numbers. And the good thing is, yes, there is a formula. So let us go to that. Now, before going to the general formula, I would like to tell you one thing, and that is, let us remember a plus b. Look at a plus b to the power 1. It is a plus b itself. What about a plus b to the power 2? It is a square plus 2ab plus b square. What about a plus b to the power 3? It is a cube plus 3a square b plus 3ab square plus b cube. Now what I want you guys to observe is, look at this. When the power is 1, there are two terms. Oh, sorry. Okay. There are two terms. When the power is 2, there are 3 terms. I hope you know that terms are what is separated by the plus, So when the power is 3, there are 4 terms. Man, do you notice something? Now, if you understood what I explained or what I showed you now, you'd be able to understand that the number of terms, the power is equal to, the power is, and between the power and the number of terms, you see that there is a relation, that is, number of terms is equal to the power plus 1. Or in other words, we can say that suppose whatever is the power, number of terms will be power plus 1. That will be the number of terms will be one extra term, one more than the power. For example, if you have a plus b to the power 5, you will have 6 terms. A plus b to the power 7, you will have 8 terms. I hope you are able to understand. This is a very important observation. Okay, now with this observation we can find the general formula. So to find the general formula, let us go to a new page. So a plus b to the power n. Now n can be a positive number or a negative number, but in 12th, I mean in this year, you are studying about factorials of positive numbers, positive integers. That is, you are not studying about -1 factorial or -2 factorial or 2 by 3 factorial. You are not studying that. You are only studying about you know um, positive integer factorial like 2 factorial, 3 factorial, 5 factorial and all. So in this 12th, and the factorials of other numbers are a bit complex, and it doesn't come in your scope, so just leave it for now. For now, this is just for this year, but remember that this n can be, so I'm sorry, this n can be any integer. It could be a positive integer or a negative integer, but for now we will just consider n to be a positive integer, because in 12th, in this year, in your mathematics, you're only dealing with such type of numbers. When you have to have the negative numbers as powers in binomial expansions, you will have it is beyond the scope of 12th. It is higher mathematics, which I think you have already enough to study, so let's not go into that. So okay, a plus b, coming back, a plus b to the power n. It is starts with nc0, then a to the maximum power, that is n, b starts with 0, that is basically 1 itself. The next term nc1, a to the power n minus 1, a power starts decreasing and b power starts increasing, so it is b to the power 1 and plus so on, this goes on. Now I want you to observe something here, that is, just look at this thing, focus on this term. If you look there, you will see that there is one term that is repeating and repeating, one term that appears again and again, one number. What is that? This one. It just appears again and again. Do you see that? So I will just substitute one variable for that. I'll consider that one as r. Okay, r is equal to 1. What will it be? It will be n c r a to the power n minus r b to the power r. Okay, so this is the formula, or the formula. Now, is this applicable? So when r is equal to 1, it is true, right? Is it applicable for all the numbers? Let us check. So let me just move this and let me take my favorite pen color. Okay, plus, so this plus nc2 a to the power n minus 2 b to the power 2. Now look at this. Again, you see 2 is repeating like that only. So we see that if r is equal to 2, then this formula is again valid, right? So we see that it's valid for every number, for nc3, nc4, nc5. We see that it's always valid. Now someone might have a doubt, sir, why is it this is not n minus r, it's only n? Why? Because here the r is 0. So n minus r is n minus 0, which is n itself. That is why I have not written n minus r here. So we see that in every term this pattern is followed. NCR a to the power n minus r into b to the power r. So what do you understand from that? What we can understand is, what actually we can understand is, this is a general formula. This is a general format. So now you have arrived at the general formula. Hooray! Now, but there's one more thing that I wanted to show you, and that is, which color should I take? I'll take white. Long time I took white. Okay, so this is your first term, right? And this is your second term. And this is your third term. In your first term, you see that your r is 0. right? So when r is equal to 0, you get your first term. Here you see r is equal to 1, that is the second term. So when r is equal to 1, you get your second term. Then here r is equal to 2. So when r is equal to 2, you get your third term. Right, this is your third term, 1, 2, 3. Third term. What do you understand from this? We understand that when what we can understand is when we use this formula, NCR into a to the power n minus r into b to the r, what we are actually getting is the r plus 1th term. R plus 1th term. That means when the value is r, the term is r plus 1. For example, when r is 0, it is the first term, 0 plus 1. When r is 1, it is 1 plus 1, 2, second term. Right, we are getting the answer for the second term. So that is why, just remember that. So in a book also you will find it written like this. The r plus 1th term is NCR a to the power n minus r b to the power r, and here you get the binomial theorem, general expression, general term format, and that's it for this video. See you in the next video.